Welcome everybody to the premiere of the SAR Insider series. My name is Abby Lehman. I work at L3Harris Geospatial and I am your moderator today. This series is all about SAR data, and so I want to start by introducing my colleague, Megan Gallagher. She's an L3Harris Solutions Engineer, and our most experienced in-house SAR expert. Her list of brainy credentials includes an undergraduate degree in geophysical engineering from Colorado School of Mines and a geophysics master's degree from Boise State University. She has been preaching the gospel of SAR within our organization since 2018, and we're really lucky to have her. Say hello, Megan.
Hey, everybody. How you doing?
Next up, I want to introduce JP Metcalf, who, like Megan, is a solutions engineer at L3Harris Geospatial. He spent 6 years in the US Navy as a strike intelligence analyst, and he has a master's in remote sensing intelligence science from Naval Postgraduate School. He spent 10 years teaching and completing research there following his master's before joining our team at L3Harris. And doing a series like this is kind of his jam, so I think that this should be fun. Say hello, JP.
Hello, everybody.
So before I get into the interesting bits, I have a few boring things to cover. First, you can submit your questions at any time through the Q&A tool along the bottom of your Zoom window. I'm going to be keeping an eye on those, and I will try to direct those to JP and Megan as we go through the show. And as the lovely computerized voice mentioned when we started, this session is being recorded, and you will receive an email notification as soon as it's accessible. So this is just one of 3 episodes of the SAR Insider series. So be sure to register for the upcoming episodes. We have one on November 10th, and we have one on December 8th. And just visit our website, l3harrisgeospatial.com, for registration info. Don't worry, I'll give you that at the end as well. So with all of that out of the way, let me just start by kind of explaining the concept of this show, because it's something we've never tried before. Megan came to me a few months back to tell me about these new SAR case studies that she was working on. And we considered scheduling more standard webinars to give her the opportunity to share them with an audience. But then JP entered the picture and we decided to go a different route. So like all solutions engineers, JP's a really brainy guy, but he doesn't have the same SAR specific experience that Megan brings to the table. But he had an interest in learning more about it from her. And so we thought it might be kind of cool to share the interactions between 2 solutions engineers, 2 SEs, teaching and learning together. So that's what you'll be part of today. Megan is going to use her case studies as a tool to teach JP more about SAR and the software that she uses to process and analyze the data. Now, before I hand it off to Megan and get this thing going, JP, do you have any additional insights about what the interest was in doing this series, and quite honestly, why you thought it was a good idea?
Absolutely. So the last time that I really studied SAR was at least 10 years ago, 2011, at Naval Postgraduate School, where we had tools like SARscape and Pulsar Pro, and took an entire class on SAR. And I remember being bewildered by the technology. And since then, a lot of new sensors have came out, like Capella and ISI, and I really wanted to do something maybe like on a LinkedIn article using SAR in SARscape. And I quickly found myself looking at a bunch of widgets and tools and parameters that I wasn't familiar with. Things like data type, like SICKET, or the single look complex or grid. And I had all these questions, and I know Megan has been working with SAR for quite some time now. And this started with me saying, hey, let's sit down. I need to get up to speed with this. And I know Megan is constantly working with SAR and has a couple projects that she wanted to show me.
Awesome. So with that, Megan, do you want to kind of take it away and get us started with the case study you're going to go over today?
Absolutely. So I'm going to be sharing my screen. In this case, I'm going to be sharing one of the many case studies that I've worked on. And then I will also be sharing a little bit of my ENVI screen later so we can talk about some stuff. So our lovely faces will be a bit smaller, but hopefully this will be able to help people understand the process I go through when I'm doing this kind of stuff.
Yeah, sad that you'll see smaller versions of our faces. I know everybody's very upset about that.
All right, there we go. So, and pretty much JP ask questions whenever you want. People in the everyone else here, throw them to Q&A. We'll do our best to answer them when they come up, because this is not me explaining it at you. This is hopefully something that we can all just sort of talk about and sort of get an understanding on. So with that, let's talk about this first case study. So the first case study that I did here was called Exploring ENVI SARscape, the Lytton fire. And this first slide, I'm actually going to take a couple seconds on, because these two images are actually of two separate fires that I processed previously in SAR. The one on the left is the campfire, which probably was the first SAR process that I ever really did in SARscape. And the colors inside of that boundary are the different dates in which the burning in those areas occurred. And then the picture on the right is the gigafire that occurred in Australia, where those areas in that sort of purplish pink color are all of the burned area. And we can do that using the same system I'm going to be showing today. But I just sort of, there's a lot of stuff you can do for fires with SAR. And that's really what I wanted to show off here.
Those are really pretty.
It's no grayscale in those, that's for certain. So if you haven't heard of the Lytton fire, here's a little bit of background. So the Lytton Creek wildfire began June 30th of 2021. The city of Lytton was pretty much destroyed by this fire, which was energized by the 2021 Western North America heatwave. If you lived in America, you probably remember the time period in which this was happening. Over 51,000 hectares were burned as of August 5th, 2021. So this was a massive wildfire that may have started because of a train track spark. There's still investigations ongoing into this topic, though. And,
wow, is 51,000 hectares a lot?
I mean, it's not as much as the gigafire, which was given an entirely new name for like megafire to gigafire for the amount of acres it covered. But I think it's not unsizable, but rather it's what it covered that was the issue for this one. So, you know, burning down a town. So similar, I forget the exact coverage of the campfire, but I think they were actually fairly similar in size, though I could be incorrect.
Wow, that's crazy to see the graphic on the right, to be driving into that.
Mm-hmm. It's just a gigantic storm everywhere for that one. So there are options when you're looking at anything with data. And though I am well known for my SAR, I do work in multispectral and hyperspectral as well. But in this case, whenever it comes to fires, I usually default to synthetic aperture radar. And the reason for this is SAR is an active imaging system, meaning that we aren't dependent upon the sun's reflectance on the Earth to get our data. So things like ash in the sky, cloud, smoke, a lot of that stuff we can see through to actually see what's happening on the ground surface. So when it comes to things like fires, or like when I'm looking at flooding and storms, I pretty much always default to SAR, though I do default to SAR in most cases anyway at this point. So we can actually see what's happening on the ground surface through all of the smoke, or most of it, as we'll see later. This is just pretty pictures of how that sort of system works.
And so on the left, you have an optical image with cloud cover, right?
Yep.
And then on the right, that's the SAR image that you can see, like you don't see any clouds, right?
Yep.
Okay. Quick question, and this kind of might be, I don't know. I haven't asked this before, but there's an interaction with the wavelength and the particulates and, you know, things like ash and water molecules. Now, when you look at fire, there's like a volume, right? Like, is it, do you think that there's like SAR can see through like fire? Like that there's not like a volume associated with that phenomenon?
I don't even know what that means. So.
I do, and that's interesting. So I would say yes, but temperature can sometimes play into things. Barely, but it can. I think it can increase noise. So if it's a really high temperature, it might be able to cause some little noise scatters in there, because you do need to keep track of weather effects sometimes when you're doing very intensive SAR scenes. So like intensive, by that I mean if you're doing what we'll be going over today, or very things that are having to do with the phase shift, which we can talk about a little bit later, I
Absolutely.
don't think the wavelengths themselves will interact with the fire itself, though, because it more so has to do with what it has been reflected off of. And I don't think any of the wavelengths of SAR that we commonly use, so X-band, which is, so C-band for Sentinel-1 is about 2.5 centimeters, X-band is less than that. So I don't think they quite reach the interacting at such a level that temperature or that the fires would cause that kind of thing. So they do interact with some things that can cause some noise issues. Snow, for example, is a big one.
Interesting.
Yeah. All right. So, great segue into this one is the technique that I like to use when I'm looking over fires is called the coherence change detection. So SAR is an active wave, and because it's a wave, that means it has two sort of responses that we get from it. One is the intensity, and the other is the phase. The intensity is the image that we see reflected back at us, and the phase is at what point in time the wave hits the ground, at what stage of its wave it's at. So using both of these together, we can pick up really unique features that we wouldn't be able to otherwise. Tiny changes that you can't see in optical data that you wouldn't even be able to see just with the intensity data as well. So you can pick up things like tire tracks and sand, which is pretty useful, but I've also found it to be one of the best ways to look at fires and what fire has affected on the ground surface.
Real quick, we say what's returned is intensity in an optical image that would normally be like a photon count, right? What type of energy do we talk about in terms of units when it's intensity from a SAR image?
So we usually actually get amplitude. It can be corrected to intensity depending upon what kind of system you're using, and because intensity is amplitude squared. So if you don't want negatives, of course, you want to go to intensity. As for the exact units, I don't remember off the top of my head because I'm just so used to working in the output units themselves. So it is just that reflected amplitude response. And so someone in the Q&A might remember it off the top of their head better than I do.
Okay.
Let's see.
What's that?
I'm trying to see if anyone has it in there. No, no one's corrected me. So we'll wait on that then. But yeah, so the point of this case study was also so that if people wanted to go and do it themselves, they could. And in this case, so I have sort of my examples here, which is the coherence change detection timeline was used, and that tracks change from scene to scene. And in this case, there are 6 Sentinel-1 scenes from June 6th to August 7th over this region to track the change from before the fire occurred to when the fire was occurred. And this lovely picture on here is actually one of those change scenes where that area in black is an area where major change has occurred, aka this area was affected by the fire. So we get to go into the sort of talking about the background of how this processing works part. I'll go through this at a reasonable pace. Feel free to interrupt when you'd like. And so the first thing you do is you start with your input. In this case, I have those 6 Sentinel-1 scenes. You can see them on the screen, exactly which ones I used. They are VV polarization, which means it was a vertical wave out and a vertical wave back to the sensor. These tend to work best with coherence because they have the highest reflectance response. VH tends to scatter more and you don't get quite as a strong response back to the sensor. So when you're doing things like coherence change detection or DIN-SAR, DEM creation, long-term time series stuff, you want to use something that is what is called co-polarized, like VV or HH. Just you get a better input for that system. You can also input an area of interest, such as a shapefile, to cut down on the area that you're processing by a lot. So Sometimes these SAR scenes can be huge. I think a normal Sentinel-1 SLC scene is 8 gigs. And so you want to cut down to only look at the area that you want.
You want to make sure that you're using the single look complex, right? As opposed to something that's geocoded already or.
Absolutely. For this technique especially. So SLC, or there are many different ways other people term this depending upon the products that they have, has the intensity and the phase products inside of it. Things like GRD, which is another one of the Sentinel-1 products, is ground range detected, and that means it only has the intensity. So because you need that phase, you want to make sure you have the SLC files, which are larger because they have more information in them.
CCD, not to be confused with charged couple device, the device that we usually see on our cell phones.
No. Coherence change detection. Yep.
Right over my head. We have a ton of questions coming in, by the way. Keep those coming, and you know,
Ooh,
Megan will keep going through this, but we'll try to get in as many as we can as we go along.
I'm sneaking a look at the questions right now. I'm actually gonna answer some of these just because they're sort of on topic, and then I'll keep going.
Okay.
So no, this is not the only way to detect wildfires. Thermal bands are absolutely a wonderful way to detect it. You can do that doing a whole bunch of different systems. This is just one way I like to see the physical elements that are affected by the wildfires, because SAR can actually give you some information on what physically has changed on the ground surface. So there are a bunch of different ways. You can use optical. People flew over this fire. A bunch of different things happened for this one, and most fires nowadays. I just like to use SAR because I can see what's happening, one, without being a nuisance, and two, because you can actually look when it's happening from space and see physical changes on the Earth's surface.
Actually, I have a question. One of the questions that someone put in here was with regard to tire prints in the sand. Are you being literal? Is the resolution that good? I think that you are, right?
I'm being literal, yeah.
Yeah.
So Sentinel-1 has a 15 meter square resolution. So that's about 50 feet squared. I just had to do this conversion earlier today, so yay for that. So you can actually see in Sentinel-1 like where tire tracks might be, but there are a lot of other systems out there with much better resolution. Things like Capella, like Novasar, like ISI, where you can have Cosmos SkyMed, ALIS Pulsar, a lot of other systems. There are so Terrace RX, I could keep going, but they could have meter and sub-meter resolutions. So yes, you can absolutely see tire prints in the sand. You can see whatever you could see with optical data, you could pretty much see the same resolution with synthetic aperture radar data. I just use Sentinel-1 because it's free, and also for case studies like this means other people can test it out too.
Although we should mention, because you know I'm in marketing, that you can use commercial data with SARscape, and that's kind of a big deal. You're not stuck with just using open source. It works with all kinds of data. Anyway, back to the nerd. Go.
I like that discussion on the wavelength interaction and using long wave infrared, that the longer wavelength isn't so affected by me and Rayleigh scattering with those particulates in the air and smoke. But you also get a different measure. You can get temperature.
Thank you, Scott, for reminding me that SAR is in decibels, because I absolutely knew that, but I swear it's early here and I haven't finished my coffee.
It is early. I have my coffee right now.
Oy. And then I'll answer one more question here and then we'll move forward. So in which spatial resolution can you map the burned areas active fire with SAR? And this also sort of relates to a previous one, which was how small of a fire can you really see, and can you see the beginnings of a fire with SAR? So this is actually pretty interesting, because what we're seeing is not the fire itself, but the effects of the fire on the surrounding areas. So when we're going to be looking at this change detection output, we're going to be seeing what the fire affected. With a Sentinel-1 pixel of 15 meters squared to 50 feet squared, we can see change, but change in one pixel is if think of it as looking with optical or a camera, are you sure that that is change? What kind of change is that? We've seen something had occurred. Maybe someone just cut down a bit of the forest, or something was moved there, like a car or a truck. When we're only using coherence change detection, which is solely looking for change, we can't really quantify what it is. That being said, when it gets bigger, we can start to look at it and go, that's odd. So there are ways to look at the change in humidity with SAR, which we can get into a little bit later, because we can see that kind of backscatter response and can actually classify it with one of the tools. But being able to immediately catch a fire when it lights would be tricky, because first off, you would have to be already monitoring that area to get what we like to call a baseline, to know what the norm is. And areas with vegetation tend not to have very stable baselines. So I'm getting a bit off track, but hopefully this is okay. Sentinel-1 has a 2.5 centimeter wavelength. Because of this, it interacts a lot with vegetation because they're about the same size. So leaves, branches, etc. It hits them, and vegetation is never static. It is always changing. So you always get that little bit of change. So with Sentinel-1, when you're trying to do things such as look at fires, you won't be able to pick up something unless it's a more drastic change, like there is no vegetation left. So you can't, I wouldn't suggest using it to try to track to be a constant, oh, a fire has started here immediately, we can see it with SAR. Probably wouldn't work unless you were already monitoring that area specifically for that kind of thing and built up a baseline of processing. It works much better once you need to see the change in an area as it occurs. So the SAR scenes I have here today are actually during the entirety of the fire, because it was a very long one. So you can go through and see how it's moving, how it's spreading. And with other systems where you can have constant coverage daily, hourly, you can fly over, then you can have that much better coverage over an area and track it while it expands. Sentinel-1 has a 12 to 14 day passing period over a lot of areas. It has a 6-day passing period over others. And so I wouldn't be able to track this as it was growing with that system. There are many others that you can task or use though. So it would be difficult to catch the beginnings of a fire. You might be able to, but I think there are other systems, other sensors, other ways that would work better in those kind of situations. For tracking ground change, it actually works really well. And the spatial resolution I used here was at 15 meters squared.
I was going to say, it sounds like something that has a larger pixel size and more of a global coverage would be able to catch fires first. Something like Veers or Goes.
Mm-hmm. So Goes is a pretty good one too. But yeah, I will now move on back to the actual process. So the second, import, this is a step that goes through and imports your SAR scenes into the sort of SARscape process. This allows you to go through and process them, import them into the SARscape format so they can go through and go into any of the other SARscape processes as well. This just makes it nice and clean to do processing and isn't something that you have to spend a lot of time on. Now we get into the actual, what's actually happening here. So the multi-temporal coherence step creates coherence between scenes. And you can think of this, I've said this word a lot, but I've never explained it so far. You can think of coherence as the similarity or difference between scenes. If coherence is 0, they are pretty much completely different. If it is 1, they are pretty much exactly the same. And so it scales between, they're nothing alike to, these are the exact same scene. Coherence uses the interferometric processing in the background to generate the similarity scaling. And you can see on the image, like on the right, so all the images on the right are the steps that I'm going through for each process. There are parameters in there, but in SARscape, you can literally go at the beginning. There's a little tool that's like preferences specific, and you can say, I'm using Sentinel-1, and it will change all of the background parameters to work for Sentinel-1. So you hit that, you go, and then you can go through your processing. It's very nice. But in this case, I actually used, then you can sort of choose what filter you want. There's the boxcar filter or the adaptive non-local INSAR filter, which is an intensive and rigorous filter, which I actually had time to use on this case study. So I got some pretty pictures out of it. And then I used the Coherence timeline tool, because what this does is it looks at the coherence between one image and the next, and then that image and the next one, to look at that change in between them, which is what I wanted for this fire. There are a couple other options, but most of the time I find myself using timeline for the things that I study.
And the max baseline is between two images or across the entire stack?
The max baseline is in between what can be for the coherence generated between the images.
Okay.
If it's too far, then it won't be generated for that scene. Okay. And this is what one of those outputs looks like. This should look very familiar, except backwards, because SAR is a non-nadir looking system, meaning it's not staring directly down at the Earth, it's at an angle. And so when it's collected, which way it's collected over the Earth's surface is which way we get our picture to start off with. So we get our lovely, sometimes upside down and backwards SAR scenes.
Where do we get the cool, colorful stuff coming in?
We get the cool, colorful stuff when I have all my processing results done.
Oh, okay, I'll be patient then.
And I have a visitor. So the next step is making sure it is no longer upside down and backwards. And this is the coherence geocoding step. We take a DEM that we have included or downloaded or anywhere that we can use, and we use that. And with the satellite data that's provided, we can truly georeference our scene, putting it where it needs to be on the Earth's surface, no longer upside down and backwards. We can see where we are now. And then the last step is to make that beautiful color picture that Abby wants so much. And this is generating statistical information about our scene and looking at the different scenes together stacked up so we can see when these changes are occurring like we would a normal optical image pile. So red, green, and blue bands will then become specific dates that we can track and see when they have either the highest resolution response of reflectance responses or the lowest. And with that, then you can choose a folder, output your data, and go.
There we go.
There's a pretty picture right there. So this is an RGB image created from 3 coherence change detection scenes, where blue was from June 8th to June 20th, green was from July 14th to July 26th, and red was from July 26th to August 8th. And the colors shown here highlight the specific time period in which the fire burned through those regions. And this is a fairly common output for this kind of thing nowadays. That campfire image at the very beginning was this exact same process for the date spread as well, just different colors. And so you can sort of see the areas in which the fire spread, but also there are some areas that are really white and don't seem affected. And this has to do with the mountains in this region or very dry areas. So we could get areas where there is change, but sometimes we have mountain valleys that we can't really see with the SAR sensor that well, or they don't have vegetation on them, so they're just very bright responses. And we can get some like rock faces and stuff, and that can actually cause us to not be able to get if those areas were burned, if there was change. So the way I like to think about this is if there was a physical change on the surface is what we usually can get when tracking with fires with SAR.
It's a lot to decode, trying to figure out all the different color combinations. It looks like there's like a river in the north, right? That
Yep.
The fire line looks like it butts up against.
Yes, a river, and then there's a valley too. I've looked up the name of that valley earlier and I've forgotten it, but there's a lot of geomorphology happening in this region.
Yeah, it looks like you can like kind of visually infer the topography.
Yeah, which is, I think that's pretty cool, but I'm also a bit of a nerd, so, you know.
Aren't we all?
I think we have to be here at this point.
Yeah.
All right, I'm going to go through, unless JP, you have some more questions on this, or you can sit on them for a while. I'm going to go through some more of these questions that we have here before we go on to the part that I'm confused about.
Okay.
All right, someone says, what is the purpose of the case studies? So the reason I do SAR case studies is actually for a lot of different things. One of them is to show that it's possible that you can use synthetic aperture radar to do a lot of different things, because here in North America, it's not that popular yet. In Europe and Asia, it is, and it's used for a lot of different things. But in North America, we don't have quite the crowd yet. Hopefully we will soon, someday, but it's not there yet. So I want to show it's possible. I want to show it's not that difficult, that you can just go through a step-by-step process. And I want to show, and I want to know what it can be used for. I got really lucky and I got some training by SARmap, the people who made SARscape. I've taken courses, I have my background in geophysics, but I'm still learning SAR all the time. You know, it's a good thing too, because I quite enjoy it. But that process, you know, is a constant thing. How does SAR affect wildfires? What can I see? Can this be usable for people? Can this help with looking at disasters? What kind of mitigations can we do with SAR? That's a constant learning thing. Like, SAR works really well for tracking brush fires, fantastically well. When we get to trees, sometimes we can't differentiate between what's a town and what are trees burning because of the reflectance response. So the point of the case studies is to see what we can do and then show people, hey, this is what you can do with SAR, and you can do this too if it will help you with what you're doing. So it's sort of a multi-step, like trying to get this kind of stuff out there deal, I suppose.
There's so many questions.
There are so many questions.
It's a good thing. I love it.
I think a really easy one is, did you get the Sentinel-1 image from ESA or the Alaskan satellite facility?
So both. In SARscape, there is the best thing ever, which is an automatic download tool. What this allows you to do is connect to both the ASF, the Alaska Satellite Facility, and ESA, or the Copernicus Hub website, to download SAR scenes on your computer in the background. You put in your dates, you put in a shapefile of your area, you can say what product you want, so in this case, SLC, and then you say, go, it'll check, a little command prompt will pop up. It'll say how many bytes you're about to download, which is a good thing because sometimes you can be like me and make some very big mistakes for what you've actually input. It's like, I don't have that much space on my computer. What have I done here? And it'll say how many scenes it's looked for. And then it'll go out and look for them for you. And it will do this all in the background so you can keep processing on your computer. And with that, I can download 12 scenes at once at max, 10 scenes from ASF and 2 scenes from ESA. And if you've ever worked with Sentinel-1, you know that a lot of the data is in cold storage. You can't access it. You have to ping it, wait for it to come live, and then download it. And so the system does that for you. It pings it, sees where it is, and 5 minutes later, it'll come back and see if it's been made active again. And so I pretty much use that all the time now because it's just so much easier to have a shapefile over my region of interest, go, here are my dates. I want descending, maybe I've looked it up on ASF beforehand to see what kind of scene I want, and then I download them from there. And it's very nice and I quite like it. So I use both, but technically I use SARscape.
There was another question that I'm interested in it.
Mm-hmm.
It says, how do you know the colors in the RGB image are corresponding to change only due to fires or opposed to other types of change on the surface?
That is oh, go ahead.
Yeah, I was going to say, I assume that there's still changes in coherence outside of the fire area due to other natural processes that still might show up.
Yeah, actually, in that campfire image, this was really annoying when I was first starting, all the way at the beginning. Do you see just south of the campfire boundary, which is in white, there are these agricultural fields there, right? That are showing up in these different colors. Because the agriculture was changing during this time period. It was growing, it was being harvested, it was in different stages. So yes, you can absolutely pick up these different changes that are occurring. We try to mitigate this by, you might or might not have noticed, when I started collecting data for this, I actually started June 6th. And this fire started June 30th. The reason for that is I wanted to remove as much noise as possible. So starting earlier would help build up a baseline of what is considered normal. And it would only be really applied for getting rid of noise, but hopefully that could help mitigate some of the change on the surface. So, I mean, I did this during the fire. So I knew there was a fire. I have the fire boundaries you can see on the screen, so I can be reasonably sure that these effects were due to the fire, but you're absolutely correct. There can be other effects that are occurring but having knowledge over the reason, having a baseline or region and having a baseline can help mitigate what is a change due to some kind of, help you figure out what kind of change is causing what, as well as the responses will differ in their intensity and such, as well as if you have a stack over time, you can track how it's changed over time. And with that, you can suss out things like, is this agriculture growing? Could this be caused by a fire? So some work does go into trying to figure out what those changes are.
Absolutely. Yeah, a whole bunch of different things can happen with such a long period of time. I mean, somebody could dig a hole and that might show up in the phase.
Yep. And I mean, the same thing happens with optical though. It's, and it is just unfortunately a way of life using remote sensing. So you've seen change on the ground. That's cool. I wonder what caused that one.
Yeah.
Is it, did something flood? Did something go wrong with the agriculture here? It's just, studying this kind of effect and hopefully getting a bit more used to it and just practice. So more case studies.
At least with SAR, you can control the illumination, where if you look at two optical images, you have to kind of back out the effects of different illumination angles. Okay.
Yeah. There's a great, do you have some tutorial to help us reproduce the same process? Yes. So that is what this is. This webinar will be published. I also have a little blog post that I'm working on that actually has a video recording of me going through this process that will be available soon too. And so this entire process will be available for you to do. Let's see.
There's a lot of questions.
There's a lot of questions.
Like, okay. I've
just
been
like
doing,
I had.
I have been doing these kind of things for a while now. I've never seen this many like legit, really good questions.
So I'm getting a lot of what polarization is best for forest fire detection. So when I'm using CCD, like I said, the highest reflectance response that you get for doing timeline stuff is with a copolarized. For a comparison of VV and HH, unfortunately, I haven't been able to do that yet to see which one might give me the better response because I didn't have an HH sensor on hand for most of these. And using VH may be possible with single scenes because it tends to get different scattering responses. But for the timeline stuff to get that stable reflectance, VV tends to work better. So it depends, unfortunately. And I can continue doing stuff to try to figure that out. But I bet there's some papers out there on that I just haven't looked at yet. So that is a great question. I will probably be looking that up in the future to try to see if I can get some better responses from it.
I want to know, you mentioned what confuses you. And so I've been hanging on to that one. I'm like, what on earth is she talking about?
Okay. This is the part that I got a bit confused at. Maybe someone in chat has the answer to this because that'd be fantastic. So with the Lytton fire and with, unfortunately, a lot of other fires that have been occurring, we had some major problems. And the problem, and well, fires are problems, of course, but I was looking at the coherence change detection output between July 2nd and July 14th, and I saw something that wasn't normal for the rest of the scenes. And I honestly am not quite sure what caused it. And so if someone in chat has figured it out, that'd be awesome. But one thing that I thought of was during this fire, there was the, forgive me for how I'm going to have to, cumulonimbus flammaginitis or a pyrocumulonimbus cloud. I have no idea how to pronounce that first one. And these are turbulent cloud structures created by fires that can have thunder, lightning, hail, and even create things like fire tornadoes. And so this kind of effect is a massive atmospheric effect because when I was looking through my scenes, I got this. This is a valley that goes through the middle where we were seeing major coherence change in both the CCD and the intensity. And this didn't show up on any of the other images. It could be noise. It could be maybe an effect of that pyrocumulonimbus cloud, like I said. But I'm not quite sure, to be honest. I wasn't there to see it. I haven't seen anything. There are no fires in that specific region right there. And that is a valley that would be a good funnel. But I honestly don't know. Anyone have some guesses?
It's a thick cloud.
It'd have to be a very thick cloud. Lots of smoke right there.
I actually just changed the settings too, so that so everyone in the audience can now send chat to these guys. So.
Oh man, exciting.
I know, so exciting.
All right, I have it up. Someone tell me what this is.
Yeah. All right. I guess keep going.
Yeah. Yeah. So my something interesting here, I'm still looking into it because that intrigues me. It could just be noise. Yes, there is a coherence image and an ITS image here. So intensity times series ratio. And it didn't show up in any of the others. So I'm watching that area with interest. Backdraft, possibly. I know it's something interesting. It's very interesting. I want to know, but I haven't been able to figure it out yet.
And it looks like it sits right outside the fire line for the most part.
Yeah, and this is like just a little valley going straight up there. I think I have a name for it. This is in between, yes, the Scarped Range and the Botany Mountain. So a possible funnel for the smoke, maybe? With that, like looking at that, my brain was like, I wonder what I can do with this. I'm not too sure, but I'm certain I can do something. Have I compared it to Sentinel-2? I don't think I was able to get an exact image on that date, but I will double check and see if there's some other sources I can look at too.
Do you think scattering happens in a cloud that large?
That's just the thing is I'm not quite sure if it is the cloud. So there are a bunch of different things it could be. Is it a dirt cloud? Yeah, with the wind vectors, you can confirm the effect of a dense cloud. Could do. I'm not quite sure what you mean by dirt cloud. Do you mean like a really particulate laden cloud? How about ash? I think it's ash personally. I think it's a lot of ash there. I'm liking people are like discussing it in here. That's wonderful. So I'm gonna let you guys keep discussing this. Maybe there'll be a surprise at the end in like a week when I actually figure out what caused this.
I think it's time travel.
You think it's time travel? Perfect. All right. And, lovely image to end it on here for my case study I made. And yeah, so in total in this case study, multiple SAR scenes, able to quickly process them to get change that was occurring over the Lytton fire. Soil gets lifted during a very hot fire. Oh, interesting. That's really cool. That's bad, but that's actually really cool. So,
and Megan, I know we have a ton of questions and you'll answer them too. The only thing I wanted to ask was about just the software for processing. This is all ENVI SARscape, but when I was talking to you about it, you said that ENVI SARscape analytics can also be used. Like, why would you use one versus the other when doing something like this?
Yes, let me grab that here because I'm a prepared person. Haha. So, ENVI, ta-da, you can now see ENVI hopefully. So ENVI SARscape and ENVI SARscape Analytics are two different like toolboxes. And what I used for this one was ENVI SARscape. ENVI SARscape is sort of the be all end all of all the SAR processing I ever need to do ever. I can mess around with parameters. I can go through and check things. I can load in any scene and do any kind of process as long as, the scene can do the process, of course, and go through all that kind of stuff. And it just is what I like to do most often because I can get my fingers in there and try to figure out what's going on with the scene. ENVI SARscape Analytics is sort of like the grab and go button of ENVI SARscape, where all I need to have is here. I can open one up here because you saw the normal SARscape one. So for change detection, for example, I can have this late image, so the image after the event, this early image, so an image before an event, an area of interest. I have DEM options. I can say if I want my classification at the end, and I choose an output folder and hit OK. That's it. I don't need to know too much about what's happening in the background. I just have to have the right scenes. So you can think of it as a version to start with, something to sort of ease you into it. So it's not quite as, I don't know if you get scared by it or it's not something that you're really used to. It's a much easier version for that. And you can get similar results. I say similar for this one in particular, because change detection is in between 2 scenes instead of in between those 6 scenes that I did for the Coherence change detection timeline that we did here. So I actually ran this earlier on 2 of those scenes, and we can see my output results here. So if you remember that picture I showed at the very beginning where we had that gray scale area where the darker area was the burnt area, you can see that here. Just a little bit different on how the output looks because this has been classified. And we actually get some intermediate products too. So we can take a look at those. It's like our ratio here, starting to look pretty familiar to that one that we did.
It always amazes me, SAR images, that it can be so like millimeter level detection, and at the same time, it just looks like TV static. Like, it amazes me every time.
Yeah.
It's just amazing that you can form an image. I mean, normally what we think of as images is usually within our visible range for our eyeballs, and then we can, when you learn about remote sensing, you're like, wow, okay, there's infrared and ultraviolet, and we can measure that with different types of metals, and then you get into this. All right, well, there's this synthetic aperture antenna in space that is constantly in orbit and can form an image that, when you start to look at the intensity, you can infer things from it, right? It's not, it's still black and white, but you add things like polarization in there and you can make it sort of look like an RGB image.
Yep. And related to that, there's a very good question in here. Now that I have this pretty colored map, what can I actually do with it? Which is a very fair question. So I actually do quite a bit with these. With the campfire one, I was actually able to map the major intensity changes to areas of the after effect of the USGS soil burn severity thing. So areas where the highest intensity change was actually perfectly matched with the areas that had the most severe burn. I'm actually working on a very much not a case study. I'm working on something right now, which is much more intensive, which is using deep learning on these burned CCDs to see if we can start classifying fires by their intensity, starting with shrubs, because it tends to work the best there for that response. And so the thing is you need to have ground range information. You can't be all flying up in the sky all the time trying to figure out what's going on. And so you can actually start mapping the changes that you see from these pretty colored maps to actual physical changes on the ground surface. And once you've built up a repository of those, you can actually start linking them together in such a way where you can see, like commonly SAR after wildfires is actually used for biomass change. And this is done in Canada really often. And so we have this pretty color map here, but all of the changes that we see here are physical, that if you have someone on the ground surface, they can be accounted for and then expanded on. So it does cause a pretty map, but we can actually go in and make this pretty map useful, which is, I don't know, I think that's pretty cool.
And what we're looking at right now is it's not like an RGB image. It's like, looks like a classification image, right?
Mm-hmm.
Significant changes in humidity, decrement, increments. Okay.
Yeah. So this is the change detection classification output. We also have filtered and unfiltered to get rid of some of the speckle. And you can sort of choose how filtered you want it to be. And yeah, so this one will actually classify it for the changes it, do not open properties, the changes it sees in between the 2 scenes that I give it. Excuse me.
So we had a question here. Is there a tool in SARscape where you can show how the fire progresses? So like with directional arrows. So for example, from day 1 to day, X of the RGB image from multi-scene CCD.
Yeah, so not in that way, unfortunately. There's not like a built-in tool to be like, this is how the change is occurring. But actually, if you have a single scene with the way SAR data is collected, there is actually a tool for tracking of motion. So if you have like a train moving or cars moving in a single scene, you can actually see which way they are moving in that scene. So unfortunately, we don't have like stage direction besides going through like with the timeline tool and seeing there's an intensity timeline tool that allows you to see what date specific thing happened at. This is my cat. He's being annoying. Goodbye, cat. And so you can use that to see the specific dates, but there isn't like an arrow tool that tracks it as it changes over time.
Let's see here. There was a few questions about just, showing active fires versus burn areas. This is an active fire, correct? This is burn areas looking back on the damage.
The fire was active during this, but this is
Okay.
looking at those burn areas specifically. I couldn't tell you where exactly the fire was during this process.
What about the seasons of the year? Does that change the footprints on the image at all?
Oh yeah. So vegetation is a problem. No, vegetation's lovely. But when you're looking at scenes with SAR, it is actually annoying sometimes because, like I said, if you have trees and the wind blows one day, you're changing how the leaves are, and that will change your reflectance response. So wind on a single day this is actually a topic for the next one of these Insider series, because that one's talking about agriculture. And there's a lot of things that can be a part of why agriculture changes between scene to scene. So wind can do it. If the leaves are off the trees, they can do it. If they're sprouting, they can do it. If the flowers are growing, it changes. And so you can catch these minuscule changes in the changes of season, which you have to be aware of pretty much. You can't not have seasonal changes, but you can be aware that they're occurring. And so when you're doing some processing, you want to make sure like either it's all within the same season as close as possible, or maybe you're doing it yearly at the same time every year, hopefully when things are as static as they can be, depending upon what you want. And so seasonal changes are something that you always have to keep your eye on for SAR, because, is that change seasonal, or is it the thing that I've been trying to keep an eye on?
All right, we only have like 8 more minutes left. So JP, it's all you choosing the questions.
I saw a really good one. It was and I'm not sure if it was directed towards fires in general, but Jasenia asked, what are the disadvantages of SAR over optical and LiDAR? And right away I was thinking revisit, where most LiDAR systems are airborne, that, if you have the money, you can get it up and fly over an area with whatever repeat interval you want. Where something like if you're relying on a satellite like Sentinel-1, very big satellites, that they have a set revisit rate, or you can get into something like Capella, where they'll have a larger constellation, higher revisit rate, and you gotta compete for tasking and things like that if it's pointable, right? So then the disadvantage is that there's a different revisit. And then you have things like, there are airborne SARs, like, is the funny word SLAR. I don't know. I don't really hear how often those get thrown up and all right, we got a fire now. We're gonna, put a SLAR on our aircraft.
I would be saying it all the time. I find every chance to say SLAR, just saying.
Yeah.
There are quite a few. So I'm going to expand on some other disadvantages there. There are quite a few. There actually are some UAV SAR sensors as well, which is crazy because the amount of energy they have to have, and they usually go through all the different bands, which is really cool. So there are options. I agree. Most of the other sensors are much more common for revisit, especially for doing the after processing to make it make sense. Because like with optical data, you just need to make sure that you put down your proper reflectance panel beforehand, and you don't do it when there are popcorn clouds in the sky. Normal UAV things to try to get your best data. SAR, the processing can be a little interesting afterwards. But I think another one of the disadvantages is just lack of knowledge, sort of, because like it's not very, in North America anyway, other places it is very well known. the lack of knowledge of how to use it is a disadvantage. And then we understand how optical stuff works. We can look at it and see this is what this looks like. We can get LiDAR point clouds and be like, this is a 3D reconstruction of this building. With low resolution SAR, you look at it and go, TV static. And that's also a disadvantage for like getting started, getting used to what does this even mean? How does this even work? Like optical, yeah, sure, I got it. Maybe this green response is a different green response. Let me use an index to try to see what changed. I can see with my eyes, like physically, there is a fire outline here. SAR isn't that, especially when you're starting off. You just sort of look at it and you sort of scratch your head like, well, there's a change, maybe, possibly. And I think that's one of the big disadvantages.
Not only do you have to understand it, if you're communicating to stakeholders for something like a fire, that you have to explain what a SAR image is and what we see in it, where an optical image, you're like, here it is. Everybody kind of like understands what an optical image looks like.
That's a really good point. That's a really good point.
I'm going to answer one more question, I think, because we've apparently almost spent the entire hour here, but someone's asking, is the Starscape workflow scriptable, either in IDL or ArcPy environments, and especially things like the data download? And so I can load this up here. The answer to that is yes, absolutely. This is the ENVI modeler, which allows you to make models. And so if I scroll down here, you're about to see a lot of SAR in here. So I can make models of my SAR process. I can link all the things together. If you used any kind of ArcGIS processing, you might have done this there as well with their tools. And then you can actually export it as, or if you are good at IDL, which I'm unfortunately not, you can write it as an IDL program. I usually export it as an IDL program. You can make a Python program. And with that Python program, you can actually load it directly into ArcGIS, as well as the Starscape analytics work pretty much natively in ArcGIS as well. So if you like ArcGIS, you just have all your stuff in ArcGIS, you can actually get the Starscape analytics in there to do specific SAR processing there for you. So it is scriptable, it is modelable, and it can go where you want it to go for your processing. So here, I should actually talk about that for a little bit.
JP, any final questions for Megan? We got 3 minutes.
If I was in the audience and I was super motivated by this conversation we had, you can get some kind of trial or eval or something like that for SARscape and ENVI, right?
Mm-hmm. I can't really tell you more because it's more on the salespeople side of things, but I can tell you yes.
Get a hold of sales. Yeah.
Well, website and then
yes.
Use that. So I'm wondering, before we wrap up, because we do have that next episode that's going to be coming up on is it 10th, November 10th?
Yes, hopefully.
So we actually had that one packed full because we're going to be looking at 2 different case studies. Megan, do you just want to give like a really brief teaser on kind of what to expect for that one?
Yeah, so in that one, I'm mainly going to be talking about, here, I can stop sharing my screen. In that one, I'm actually going to be talking about intensity processing with SAR. So just the reflectance that we get, because this sometimes tends to be overlooked and it's still an exceptionally powerful tool. And we're going to be looking at agriculture changes. And for one example, looking at rice in Vietnam, I have some fields over Boise for one single picture. And then looking at deforestation in Brazil, because we're able to track these changes, even when the weather is not really working with us, which is a problem for a lot of things like agricultural and deforestation monitoring. So we'll be going over those processes and just taking a look at what kind of outputs you get and what information you might want to get from it.
And if obviously we had a ton of questions, if people afterwards want to get in touch or ask questions, how do they do that? How do they send those to you?
Yeah, so I did have my email up for like 0.3 seconds on that last slide there, but you are free to welcome myself, or if you want to inundate JP as well, you can do that too. To ask any other questions you might have had on this.
You're welcome to send them to me, although I don't think I'll be very helpful.
Send them to Abby.
Yeah, send them my way. Great answers. Okay, guys. Well, yeah, when we'll send out that contact info as well when we send out the link for the recording, which you will get shortly. So make sure to go out to the website, L3HarrisGeospatial.com, and you can register for the next 2 webinars. And well, they're not really webinars, cool sessions, for the next 2 cool sessions. But I think that's it. Thanks so much, you guys.
Absolutely.
Great day.
Thanks. Join us for the next.
Yeah. See you later.